In an earlier video, I showed how I repaired an EST snowboard binding by reverse engineering the missing part and recreating it using SLA 3D printing and CNC milling. The approach worked really well, but enough is never really enough, is it? I decided to explore a different approach, one that is more affordable, faster and cleaner. Here you can see the reverse engineering process. In this case, I chose to 3D scan a reference part. From that scan, I extracted the geometry and created a digital model that can be used for manufacturing. If you're interested, I can make a separate video explaining when I use 3D scanning and when I don't. Because in contrary to what people want you to believe, it's not always the best option. But why am I really doing this? For my customers, it means that they can keep using their favorite bindings. For me, however, it's something else. I like to reverse engineer stuff. My colleagues are Dutch. They would look at me and say, you like copying stuff. But I also like to explore how accessible the digital manufacturing technologies like 3D printing can be used to extend the life cycle of products reliably and at a reasonable cost. In many cases, a product isn't really truly broken. It's just missing a small part that is often critical for usage. If we can recreate those parts, we can keep products in use longer and reduce unnecessary waste. But it's also about ownership. The EU Right to Repair directive is a step in the right direction. But as a design engineer, I know that products can still be designed in ways that makes them hard to be repaired. Mass manufacturing has made products more efficient and widely available, but it's also a double-edged sword. If losing a small part, like a footbed, makes your binding unusable and pushes you toward buying a new one, then you have to really ask, do you really own the product or does the product own you? In this case, I'm using a snowboard binding as an example, but it applies to many different products we use every day. So for these EST bindings, I've got two working solutions right now. I have the SLA printed part with a CNC milled bed. Very interesting because the materials are by nature isotropic. The SLA printed part is semi-isotropic, but it's still isotropic and thus, in theory, more reliable. But it comes at a higher cost. And I've got the second option, which is the FDM printed parts, and these are more affordable. They're not isotropic, but they have this very cool lattice structure inside that makes them both lightweight and very cool to look at. Here you can see how I'm attaching the new replacement bed to the binding so the client can start using his bindings again. And so now the question is for you. I'm really interested to know, which one would you choose? Would you go for the SLA version or would you go for the FDM version? Thanks for watching, and remember, don't throw them away, fix them.